Here's the solution for day 1, problem 1. In part A, it says rewrite the number into standard form, and we're given this number, which is in scientific notation. So let's begin by copying that number down. When I copy it down, I'm going to leave a little space here before writing the times 10 to the 5th power. And the reason I did that is because I'm thinking ahead to what's going to happen if I multiply this decimal number by 10 to the 5th power. That's going to end up moving this dot to the right, and so I'm creating some space here to accommodate that. Right? Multiplying by 10 to the 5th power has the effect of moving the decimal point 5 spots to the right. So let's do that. 1, 2, 3, 4, 5. The decimal point's going to end up here, and these 2 spots need to be filled in with placeholder zeros. That's going to create the number 2158, 0, 0, then the decimal point. To make this number a little easier to identify, you can come 3 spots to the left from the decimal point and toss in a comma, and now it's a little easier to see this is 215,800. Part B, rewrite the number into scientific notation. So here we have a standard number, 718,000, where the decimal point is at the very end of it right now, and we're asked to change this to scientific notation. The key to doing this is to realize that any number in scientific notation will have only one number to the left of the decimal point. That means the decimal point needs to be moved here so that this digit 7 is that number that's to the left of the decimal point. So let's count how many spots we need to move the dot to accomplish that. 1, 2, 3, 4, 5. 5 spots. That's going to create the number 7.18, and now times 10 to the 5th power. That exponent comes from moving 5 spots. Now day 1, problem 2. In question A, we're asked to solve this equation, so to find the value of the variable n, and then in question B, we'll check whether our answer is correct. So question A, let's write that equation down. And to help me keep the left side separate from the right side, I'm going to draw a line downward from the equal symbol and solve this for the letter n. When I look for the variable n, I notice an n term here and an n term over here. We don't want to have the letter n on both sides of an equation if we're trying to solve for the letter n. So let's remove this n term from the right side of the equation. So under 2n, subtract 2n. And to maintain balance, subtract 2n there. 8n subtract 2n is 6n. The minus 3 can be brought down, equals 2n subtract 2n is 0n, or just 0. And then the positive 15 can be brought straight down. So we've transformed this original equation into this new equation, which is simpler looking. Now we want to solve for n, so let's find the n term. Here is the n term. Next to the n term, there is a minus 3. Let's remove the minus 3. Opposite of minus 3 is to say add 3. And over here, add 3. The 6n comes straight down. Negative 3 plus 3 makes 0. And then equals 15 plus 3 is 18. So now we have the equation 6n equals 18, or another way to think of this, 6 times n equals 18. Let's solve this for n. We can remove the coefficient of 6 using division. Divide 6, divide 6. 6 divided by 6 is 1n equals And 18 divided by 6 is 3. So if 1n equals 3, that just means n equals 3. So here is the answer we think is correct for n. And in part B, we're going to check whether that really works. So take the original equation, and where the variable n is, here and here, we're going to substitute in the answer we think should go here. So it will be 8 parentheses 3 minus 3 equals, and then over here 2, and then fill in the letter n, and then plus 15. So the question is, does this expression really equal this expression? And if they do, then we have the correct answer for n. 8 times 3 is 24. And 24 subtract 3 is 21. Let's see if this also makes 21. 2 times 3 is 6. And 6 plus 15 is 21. Does 21 equal 21? We're wondering? Well, yes, it does. And so this checks, and n equals 3 is the correct answer.